So my name is Patrick. I'm working as a product manager in charge of infrastructure tools at ARM, and we are very actively involved in the open source community. We make a lot of contributions, and I wanted to share a bit about what we do and how we are working with SUSE in order to be successful in HPC. So for those of you who don't know ARM, basically we are a semiconductor provider. So the unique thing about ARM is that really we design intellectual property, we design blueprints about what a processor should look like. And we provide this already in all the phones, most of the phones that you will have. And ARM is making a very strong push in the infrastructure segment and in HPC at the moment. And one of the key things that we do in order to be successful is we know that being successful in HPC is not just about having good hardware, it's really about building the right ecosystem, making sure that people have access to the right operating systems, the right tools, the applications, that everything is running well for them. And in order to achieve this, we work on multiple components with various people, such as SUSE, in order to make sure that the ecosystem is here. So one of the cornerstones of the work that we're doing is really working on the software tool side of things. So ARM provides cross-platform tools that will work on Intel, x86, AMD, power systems, GPUs. So this is what we call the basically DDT map Forge as a whole, which is debugging and profiling tools. We also provide ARM-only environments, so basically the compilers, the libraries, all these kind of things that are really designed for ARM machines specifically. Now the really interesting thing is that what we do is that we take the open source projects, so typically GNU, LLVM, we put in them the new things that ARM is having. So for instance, we're working on things like SV, which is a vectorization for ARM chipsets. We include support of this in the GNU compiler and LLVM. We package that, we sell that up front, and as soon as these environments can be made public and can be upstreamed, we upstream them, so there is a bit of latency, but all the work that we do ultimately makes it back into the various projects. And this is the example of GNU, which is part of our Linear Studio. And as you can see, we are the second largest contributor to GCC and Fortran over the last few years, which is extremely good, because we are trying to break the picture that when you're using GCC, you will get subpar performance. This is a strategy that Intel had in place, where they were providing their competitive solution, which was, well, the Intel Parallel Studio with their proprietary solution, and GNU had a hard time to keep up with that pace. We take the problem in reverse. What we want to do is to make sure that GNU compiler is as good as possible. And the same goes with LLVM compiler, which we also call the ARM compiler in the way that we provide it. So basically we support it, we tune it, fine-tune it for applications that are running on ARM. We are supporting all the architectures that our partners are developing. For instance, Marvell is doing ThunderX2, Fujitsu is working on their own core, so we are tuning the compiler to make sure it's really performant on this environment. And basically what we do, this is the architecture of the compiler. As you can see, we're using some front ends, so based on Flong of Clong, and we work really on the back-end side of things. So all the work that we do ultimately makes it back to the open source community, which is really important. The other angle that we take is working on the libraries. And again, all the work that we do eventually makes it to the upstream projects. And as you can see, if you look at the performance, we've compared the numbers on ThunderX2 systems based on the Open Blast, etc. We always have a slight competitive edge because we want our products to be good, but at the same time, we contribute to Open Blast and to the other projects to make sure that we bring up the level of the performance for the greater good of the community. So running some benchmarks using the ARM suite on the ThunderX2, we've got a lot of people who have deployments as we speak of ARM-based systems. So this was some numbers that were presented by our partners, GW4. So they have a Cray machine called a Zambard, which is an XT650 with ThunderX2 servers. And as you can see, we've managed to get some very, very interesting results in terms of performance. And we've done some comparisons against GCC with the ARM compiler, with the Cray environment. And they are actually very positive. So what we've found is that if you have workload that are very memory intensive, actually the ARM systems that we provide are really, really good, and they come with the whole software stack, which is fully commercially supported So if you've got an issue, we will be there to help you. Even if it's an issue with the GNU compiler, our support team will help out. We will provide you with bug fixes and we will upstream them ultimately into the project. And this is our key value add. So apart from that, we also work on other open source projects. So we've got some tools that help understand what are the biggest FFT calls that you're making. So this is really useful information because it helps us, if you run these tools on your application, you will get basically the list of all the calls you're making, which ones are the most predominant. You give us that list, and it helps us prioritize our work to make sure that we optimize the libraries and everything for your workload. So we are very eager to do that. And we also contribute to the Open HPC community, so we make sure that people who are deploying systems, they can have immediately something that they install on the ARM-based machines. It works out of the box and it works with high performance. So this is our key focus. So basically what we're doing is that we're relying on our silicon partners to provide good performant hardware that will bring you value. And what we do is we make the migration costs of moving from Intel, which is the predominant architecture at the moment, to ARM as small as possible. And this is only possible thanks to all the tools that we are working on everywhere. So if you want to contribute, we have multiple pages which are open to the community. So this is our GitLab, where we basically post our recipes. So this will typically include all the things to make open source applications work. So if you take OpenFOAM, if you take LAMPS or GROMACS or whatever, we make changes to these applications, we upstream them straight away, but there is always a bit of latency. So if you're interested, all the recipes are posted there, so you can just pick what other people have been doing. And similarly, if you're working on porting an application to ARM, we encourage the community to just put this here. We take care of the upstreaming after that. So please feel free to contribute. Right, so if you're more interested to see more, we're very active. We've got newsletters, we've got a blog post. So here are a few pointers. And if you want to reach out to me, have a discussion about ARM, please do feel free to send me an email or just catch me after this presentation. I'll be very happy to have a chat with you. And thank you very much for SUSE for arranging this small presentation. And I wish you all the best. Have a great show and enjoy your time in Dallas.
All right.